Hello, everyone, and welcome to the continuation of the 7.1 and 2 video on linear and nonlinear systems. This half will deal with the word problems. So the first one says a total of $12,000 is invested in two funds, paying 5% and 3% simple interest. You may need to know that the formula for interest, if you've forgotten, is interest is equal to principal times rate times time. The yearly interest is $500. How much is invested at each rate? So a really good strategy for starting a problem is actually looking at the end sentence to decide what your variables are going to be. So let's say that X is the amount invested at 3%, and Y is the amount invested at 5%. So I know that seems very middle schoolish to take the time to do that, but sometimes you need that just to figure out what you're going to do next. And then, of course, we have to figure out a couple different equations. These are systems, which means there's going to be more than one equation. Well, first of all, we know that 12,000 is invested, some at 3% and some at 5%. So our first equation is just X plus Y is equal to 12,000. And then on top of that, we know that the interest that you get from the two of them is going to total 500. Well, the interest that you would get from the amount that you invested at 3% is going to be whatever that amount is times the rate, 0.03, times the time, which is just 1 year. And then you've invested some money, Y dollars, at 5%. So those Y dollars, that's your principal, times your rate, 0.05. Remember, rates are always expressed as a decimal, also times 1 year. And at the end of the year, the interest you got from the X account and the interest from the Y account is going to be a total of $500. This is your system of equations. Remember, you have several methods to solve. We could graph it. We're not going to graph it. Or we could use substitution or elimination. So I'm probably just going to use substitution. So I'm going to change this to Y is equal to 12,000 minus X and substitute that in. So this is 0.03X plus 0.05Y, but in place of Y, I'm going to do 12,000 minus X is equal to 500. So this is going to come out to be 0.03X plus 600 minus 0.05X is equal to 500. Bringing the 600 to the other side gives me negative 100, and the 0.03 and the 0.05 make negative 0.02. When I divide 100 by 0.02, I get $5,000. And since the two of them totaled made $12,000, I know that they must have invested $7,000 at 5%. Remember, this is a word problem, so you can't just box X and Y because there's no X and Y given. It's a question. How much should be invested at each rate? You need to answer in an answer format in a sentence. So you should invest 5,000. I don't know if you know that 5K is another way of saying 5,000 at 3% and 7,000 at 5%. Number 11. An airplane flying into a headwind travels the 2,000-mile flying distance between Chicopee, Massachusetts, and Salt Lake City, Utah, in 4 hours and 24 minutes. On the return flight, the same distance is traveled in 4 hours. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant. So like I said with the last one, sometimes it helps to define your variables by figuring out what the question is. So find the airspeed of the plane. So let X be equal to the airspeed of the plane and the speed of the wind. Y is equal to speed of the wind. So what they don't give you in this question is that the formula distance is equal to rate times time. It's pretty much understood that people know that, but the truth is I think a lot of people don't know it. So there it is for you. So we're going to write two equations. In one case, you have a distance of 2,000, and then you have the rate times the time. So one time it took 4 hours and 24 minutes. So of course, we're actually going to have to convert that to a decimal. So 24 out of 60 is going to translate to 0.4. So 4.4 hours. But the rate wasn't just the speed of the plane. When it took him longer, that's because he had a headwind. He was going against the wind. So it's like the wind was hurting his speed. So we can say x minus w times 4.4. And then on the way back, it was still 2,000 miles, but now he has a tailwind, which means that the wind is actually helping him go even faster, and he makes it in exactly 4 hours. So the natural inclination is to distribute this 4.4, which is a really good thought. But I'm actually going to show you just a little bit of a shortcut. And that is I would divide both sides by 4.4 first. And then you'll have a really easy equation. So 2,000 divided by 4.4 is 454.545 is equal to x minus w. And then this one's a little bit easier. 20,000 divided by 4 is exactly 500 is equal to x plus w. So again, divide both sides by 4. And why did I do that? Because now I can use the addition method, which we actually haven't used, I think, this entire time. So this gives me the w's cancel, and I get 2x is equal to, and fortunately, I still have that number on my calculator, the exact number all the way out. So I can just go ahead and hit plus 500, and it gives me 954.545, but still everything else is there. And then again, divide by 2 while everything else is still there. I get x is equal to, it just kept my answer very precise, 477.27. It's actually 27 again, so I'm going to write 273. So that was the airspeed of the plane. So the plane, remember, answer in a complete sentence, is flying at 477.273 miles per hour. How do you find the speed of the wind? Well, you can use any of these equations, but it looks to me like this one's going to be the easiest. 500 minus x will give you w. And so the wind speed is 22.73 miles per hour. Number 12. A shoe company invests $30,000 in equipment to produce a new line of athletic footwear. Each pair of shoes costs $5 to produce and is sold for $60. How many pair of shoes must be sold before the business breaks even? So in order for them to break even, you need their investment to equal their revenue. That's when it would break even. So their investment is going to be $30,000. And then every time they make a pair of shoes, it costs them $5. So how does that work? The $30,000 must be for their equipment and for their location, and then for the employees and all the machinery. But then each actual shoe takes $5 to produce all the materials that are needed to put into that shoe. So 5 times X. Every time they sell a pair of shoes, they have 60X. They make $60 off of each one. So I can solve this pretty easily. 30,000 is equal to 55x. X is equal to 546 pairs of shoes. It doesn't actually come out to be exactly that. It actually comes out to be 500 and 45.45 pair of shoes, but you can't have part of a pair of shoes. So we're going to round it up to 546. If they only do 545, they won't actually come back to zero. They'll still be just a little bit short. So they need to sell 546 pairs of shoes. Now you might be thinking, well, we didn't make a system. We didn't do this the normal way. I purposely did it differently to show you that sometimes you're going to do a problem differently and you want to know, is this okay? It absolutely is. So their cost, this is how they expect you to do it. Cost is 30,000 plus 5x. That would have been equation number 1. And then revenue is equal to 60x. And then at what point is C equal to R? And then you could have used substitution. But as long as you're thinking the problem through and you have a mathematical way of doing it, it doesn't need to be by the book. It needs to be well thought out and mathematically correct. Number 13. The weekly ticket sales for a new comedy movie decreased each week. At the same time, the weekly ticket sales for a new drama movie increased each week. Models that approximate the weekly sales tickets, S, in millions of dollars for each movie are given here, where X represents the number of weeks each movie was in the theaters. X is equal to 0 corresponds to the ticket sales during the opening weekend. After how many weeks will the ticket sales for the two movies be equal? So again, we want 60 minus 8x is equal to 10 plus 4.5x. So even though this is in this section, which was otherwise pretty challenging in the first half, these are very, very straightforward. 50 is equal to 12.5x. 50 divided by 12.5 comes out to be 4. So after how many weeks? After 4 weeks. Okay, last one. The demand and supply functions for a new type of personal digital assistant are, and then they're given here below. I need to take a minute and explain what that is. This book and these questions are literally from early 2000s. And the precursor to a smartphone was called a PDA. You might have heard of a BlackBerry personal digital assistant. And before people had smartphones, this was a way for them to communicate. So the price and how many units they make, they have these things called demand equations and supply equations. So if you're thinking about going into the business field, this is a great example of how math is heavily involved in business decisions. You want the price and the number of units you make to satisfy both the demand and the supply equations. So you can do that pretty simply by using substitution. I'm going to have this go right in there for P. So 150 minus 0. And honestly, the only place people go wrong on this problem is the number of zeros. 1, 2, 3, 4. 1, 2, 3, 4, 1. X is equal to 60 plus 1, 2, 3, again, just 4. 0.12342 X. And this is very straightforward algebra, so I'm not going to torture you with doing it out. The answer is 3 million. So remember, that represents the number of units. And then they still want the price. So if you plug 3 million in for X, then the price will be $120, which, by the way, back in the early 2000s, people thought that was outrageous. And now what are you guys paying for phones? $800,000 for your iPhones. So we've changed a lot since then. All right, that is it for sections 7.1 and 7.2. Have a great day.